problem, and I realized I had to do it, and I'm like, oh.
So no questions from homework? Good. All right, I'm an optimistic fool. Take that to mean it's happening and it's going well. Even though I know some of the problems are freaky, but fine, okay. So the first thing we gotta do actually is finish up this sheet from last time. The one that had section 5.5 on one side and it had integral practice on the other side. Let me put it up here so you guys can see what I'm saying. So it says 180 integral practice on one side, and then U substitution on the other side. Did you turn on? You did. There we go. So we did 2B, but then I think we got to do the rest of 2. There we go.
I didn't get that update.
All right. Anybody else need this? Okay. So we finished up the first part, which was F.2. This guy. So, like Ricardo said, when you're doing this definite integral, you don't need the plus c because it's understood it's going to cancel. And that, of course, kind of sucks because when you learn this, you start forgetting the plus c for other things. So trust me, I lived that experience, but I'm not going to be nice to you. Huh? All right. So 2 is from section 5.4. And here's the connection between definite integrals. These are definite integrals because it's defined over an interval. And these are indefinite integrals because they don't have an interval over which they're defined to be, right? Does that make sense? So these are more general. So the connection between this and this, can you guys see that? There it is. The connection between these is this equals this evaluated between B and A, right? So this by itself just says find big ass f of x. So it's when you see this, it's section 4.9. Find the antiderivative. That's what it means. This means find the antiderivative and then evaluate it between the two. So in a sense, these are easier, but they're in a later section, so go figure. So what do you guys think about this one here? How would I integrate x to the -2? What's its antiderivative? So when you differentiate, the power goes down by 1, right? And it comes down. So when I integrate, what's going to happen to the power? It's going to go up 1, so it's going to be at where? -1. I love it. And when I differentiate, I multiply by the old power. When I integrate, I divide by the new power. Why does that make sense? Because differentiation and integration are opposites. So this is what I do when I have polynomials. Figure out the power and then divide by it. That's integration. Exact opposite of differentiation. And what about 3? 3 kicks ass. 3x kick it. Thank you, 3. So let me just rewrite this a little bit. Bam! And of course, how can you always check the answer to it? And take the derivative. Derivatives are easier than integration, yes? They have to be, because they're funky enough and the integration is trying to go backwards. Okay. We did part B already. And again, you got to be really careful. Somebody's always going to tell me this. This is always neat to get. Right? But is pi a variable? No, it's a definite number. It's a constant. And the variable is t. So I'm like integrating 3. So But that would be 3t, so integral pi is pi t plus c. Does somebody have a suggestion on part C?
Rewrite it.
Yeah, simplify the damn thing, right? Do we have a quotient rule for integration that you know of? No, and we don't, period. It just doesn't exist. Too damn bad. Right? So we still have to learn what there is. That's kind of like analogous to product rule, chain rule, all that kind of stuff. But we definitely don't have product rule. We don't have chain, we don't have quotient rule. So when you get something like this, you think simplify. Because otherwise, ain't shit you could do, right? So, how could you simplify that?
And sine over
Yeah, what's tangent?
Sine
Sine over cosine. What's secant?
1 over.
1 over cosine. So the cosines cancel, so you're just left with sine. So it's the integral of sine. What's the integral of sine?
negative cosine.
Look at that. Kick it. Somebody else came in there with the plus C. Yeah. Sweet. By the way, that 19/3 is from up here. So it's not right. Okay. So there's that. So always simplify first if there's anything you can do. Yes, sir.
So what's that little, is that beta next to sine, or?
That's theta. That's trying to be theta. That's what my theta looks like. It looks like somebody leaned against it or something. It's had a rough life, all right? My thetas. My thetas. So let's see if this extends. What can I do with part D? Yeah. So if I rewrite this inside, I'm just going to look at the inside. How do I rewrite that? And that's divided by x squared. 4x divided by x squared. 2 divided by x squared. So this becomes, what is x to the 7/3 divided by x squared? The what? Yeah, 2 is 6/3, right? So you subtract, so 1/3, x to the 1/3. Minus,
4x to the power of -1.
I like it. And then plus, let me write this as this. Now I write this one like this because what is the integral of 1 over x? ln of? Absolute value of x, yes. And then, okay, so you're totally right. I could have written that x as x to the -1 next to the 4th, right? But I remember 1 over x goes to ln, right? The other dude is the rule. You take the power up by 1 and divide by the new power, right? The 1 over x doesn't follow that rule. In fact, real quick, I haven't shown you this, and I'm not going to show people at home too bad. Remind me again, what would this be?
1/3 x.
Yeah, no.
All right, so if I try to use that same rule on this, try to use the exact same rule, what does the power go to? 0. And I divide by the new power, correct?
0.
Yeah, so, and plus C. What's the point of plus C? Because you sit next to freaking infinity, right? So natural log of x bridges that gap that we're left with. That cannot follow this rule because you end up with something that's not even undefined. It's, well, it is undefined, but yeah, it's gross. All right. So let's finish this out. How do you integrate x to the 1/3? What's the power go to?
3/4 x to the power of 4.
Yeah, so the power goes 1 up. The shortcut is 1 plus 3. And then I take this and I reciprocate it because I'm going to divide by it, which means multiply by the reciprocal. Minus, like we just said, 4 natural log of absolute value of x. 4 is just a constant. Don't let it bother you. It just sits next to the answer. No big deal. And then what happens here? The power goes to -1. So then I have to divide by -1, which means change the sign. There you go. Plus what? I like it. Right? Is that right? Now listen. I know there's kind of a lot going on. You have to think backwards. right? But again, this integration just takes some getting used to, and the differentiation takes some getting used to. What about, oh boy, all right, let me get some room for this one. What about this guy? All right. What do we always do? What do we always try to do if I'm like looking at something I have no idea? Simplify. Any suggestions on how to simplify that? Will that do anything? No. But I appreciate that, right? You can factor an x out of the top, but it doesn't really lead to anywhere. If only that was a 5 instead of a 3, right? Yeah. Screw you, Jeff. All right. Anything else? Any other suggestions on what you try to do? You totally could. But again, yeah. So, just to remind you guys, isn't that a fraction? What does fraction mean? Division. I'm going to long divide, or I could synthetic divide, right? Did I give you the synthetic division handout a while back? No? Not yet? But we did talk about synthetic division, yes? So what it goes in the penalty box? You guys remember? -5. And then what are the coefficients? 1, 3, and 0. You got to represent everything. 1x squared, 3 x's, no constants. All right, and then how does this weird shit work? One comes down.
Multiplied by -5.
-5 times 1 is -5. That's a long ass one. Okay.
Add it.
Add it.
Multiply again.
Multiply.
-5.
Add it. So what does this mean? It was x squared plus 3x, and I divided by essentially x. And now this is 1x minus 2 plus 10 over x plus 5, right? So let's rewrite this integral. So this becomes the integral of x minus 2 plus 10 over x plus 5. Now,
why is it 10 over x over 5?
because that's the remainder.
Oh, that's right.
It's sort of like 7 goes into 8 once with 1 left over, so it'd be 1 and 1/7, right? So this is this and 10 these. X plus 5th. Same exact way.
So the last one is always the remainder.
The last one's always the remainder. So if it's 0, that means it went in perfectly, which means it would factor.
Okay.
Yeah. If that would have been a 5, this would have canceled. That would have been 0 again. Okay. Let me do the first part. Oh, look at me go. Oh man, that was hard. Okay. What happens? I did like 2/3 of the problem. Jeez. Does anybody 10 over x plus 5?
Couldn't you just bring it up because the derivative of the inside would just be 1.
Sure. So what's the integral of 1 over x? Natural log of absolute value of x, right? What's the integral of 2 over x? 2 natural log of absolute value of x, right? So this will be 10 times the natural log of ln absolute, yeah. Like Ricardo said, this stupid little thing down here has a slope of 1. There's no chain rule that I have to be careful about. So it's plus the constant times the natural log of the stuff on the bottom. Absolute value, right? Plus the value. So again, simplify the original question saved our ass. So yes, long division or synthetic division will come in sometimes. Okay. There's one thing I might show you. We'll see. It's not absolutely necessary, so maybe I won't show you. All right, so that's section 5.4. There's a little bit more in 5.4, but just to remind you guys, you have a book with examples. It's crazy. Yes? You also have a teacher that you can come to and ask questions. It's crazy, right? So most of it's going to be like this. There will be some extra little things. We'll see how you do. Okay. Any questions about this worksheet? Oops. There's that one. There's that one. Yeah, okay. So, Now, we're gonna start to work our way into section 5.5. Right. And at least one person has tried to get ahead a bit and has realized it's not too crazy, but it is a little crazy. So I'm gonna try desperately. I think I've come up with a way. Okay, let's see what you guys think. Real quick, guys. How would you, this is going to seem completely unrelated, just to let you know, right? So we're going to do something that seems completely unrelated, it'll come back somehow, unless I've gone completely insane, which at any moment could be true. Let's all find out. So how would you factor that? U squared minus V squared. How would you factor that? That's what I call a thank God problem. Or a thank whatever your deity is. The god of coffee, the flying spaghetti monster, thank whatever, right? What is that? How do I factor that? Please, it's easy as shit. I'm going to just say that directly. I don't care how you feel about it. It's easy as shit. How do you factor that? Come on. There's two U's, yes? So don't you put one over there, one over there? Two V's, one over there, one over there? Minus plus. That's why there's no middle term, right? What is that called again? Difference of squares. Yes, yes, yes. Difference of squares is easy as shit, no matter what. No matter what. So let's see, let's test what I just said, right? Note. One. Let me do one thing. You can do whatever you want to, Joe. It's your class. Just make this X's. And we'll make that into part. Don't need to make it all too crazy. Now, if I give this problem to a student and I say factor this, the immediate thing what do you think the immediate thing is they start doing? And maybe you're thinking about doing it. Foiling it out. But isn't that the opposite of factoring? Now, does that mean a factor problem will never need you to force? No, but normally that's going against what I'm asking you to do. Can anybody see what form this is in? What form is this in? How many terms are there? There's two. And I'm taking the difference of them, and they're both, holy shit, so it's in that form. So look what I could do for you. Look what I could do. What is this? Can anybody tell me what that is? Can somebody just tell me, is it 6? Is it yellow? Is it a feeling of melancholy? What is that? Does anyone know what it is? Go ahead, tell me. Do you know what it is? Say it. No, not what is it like. What is it? What's the answer? Can you tell me? I know you're all like, what's wrong with this guy? Did I tell you what X is? Can you tell me the answer? No. Okay, we don't know what it is, right? We don't know what that is, do we? All right, I'll stop. I'll come back. This is so cool, though. So what do I do in algebra when I'm faced with something I don't know what it is? Can't I give it a variable name? So do we know what this is? No. Let's call it U. Do we know what that is? No, let's call it D. Isn't that the form it's in? I really want this understood. Has anybody ever seen that before? Did any of your pre-calc teachers or algebra teachers? Well, that sucks a lot. But, oh well. I really want this to make sense. Isn't this true no matter what this is and no matter what that is? Isn't that true? This looks harder because there's extra detailed shit getting in the way of the form. Does that make sense? The minute I say U equals that and V equals that, why am I allowed to do that? That's the fundamental idea behind algebra. I got something I don't know, let me call it a letter and do shit with it, right? So how do I factor this? And do you think you would circle that as the answer?
No.
Why not? Because the question had, what?
You got to combine all of them.
Well, there's nothing to do here. What do I need to put back in? What the shit U and V are, right? So this is neat. Momentarily calling this big ass expression U and that one V helped me see what form it was in. And then it's easy, and then the last thing I do is I plug you know, there's u. Minus, there's v. And then I can do what Ricardo said, right? Times, there's u, and minus 3. Plus 7, there you go, John. Plus, minus 3. All right, I don't care about the rest. You can bring the negative 3 or get your like terms, put it in each of like, right? Is everybody with me? Oh, that made it so much nicer when we did this one thing. Does this feel a little bit like cheating? A little bit, right? But I desperately, the whole idea of something like factoring is, what form is it in? Then I know the process to do. Can I easily see the form this is in? No. By saying this shit is you, because I don't know what it is and that shit's me, I can then uncover the form, attack the form, and then put the details in at the end. So I understand, this is the first time you've ever seen this, it feels a little bit like you're cheating. But again, I don't know what the shit this is. Let me call it you. Okay, so how does this relate to anything we're doing, right? That's a good question. I don't know. Oh yeah, that's right. Okay. There's more to do, who cares? Where'd you go? There. So help me out. And I've done this before, but let's do this one more time. Let's take a trip down memory lane. What would the derivative of that be? Yeah, good. The derivative of this, right? Blah, blah, blah. I don't care about the blah, 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 right? There's more work for that, but I don't care. That's the point. What if I had this? Doesn't matter. Let me just use one. Yeah. Oh, wait. Before I do that, make one little point here. What's the other way to write this? F prime? What's the other way to write F prime of X? Maybe using the letter D? I don't know. DF?
DF over, yeah.
There it is. Okay, just keep them. What if I had, doesn't matter, John. Yeah. What would this guy's derivative be?
1/2 tan x times the derivative of tan x.
1/2 tangent x.
So far,
Negative 1/2 times the derivative of tangent x, right? So this would be dg dx equals that. Right? You're all like, this is so amazing, Joe. I've done this before when we talked about chain rule kind of stuff. We talked about even when we did implicit, I did this a little bit. All of this means that if I had a function that looked like this, I really want you to understand. Did it matter at all what the function in here was for the first step? Didn't matter at all. It didn't matter worth shit. It would matter the next step, because then this derivative is 2 and this derivative is secant squared, right? But the process I used at first didn't give a shit what that function was. So it could be any function of x in there, yes? And then so how would it work? No matter what that was, how would it work?
1/2 u x and times derivative, or negative 1/2 times derivative.
Right? And what would this, so let's see, this would be dh dx, right? Yeah. Times du dx, right? So this would be, you see how the dx's can cancel? So this would be dh equals 1/2 u of x to negative 1/2 du. Did anything really amazing happen there? I said prime, that's nice prime, let me write it the other way, and then see how the dx's cancel, right? So I didn't do anything amazing. So let me ask you this. So I can do the same kind of thing here. I can multiply this dx up. Can anyone tell me what the integral of this would be? No work to do. There's no work for you to do. What's the integral of this? It's this, yes? Yes, right? Isn't that how integrals and different, if I take the derivative of something, the integral of the answer takes me back to the original because those are opposite things. So what would the, how do I handle this? Oh, there's T, G, yeah. What would the integral of this be? That, right? Plus C, because it's not definite, but you guys are with me, okay. So, if I'm asked, here's what's important. This integral was easy because I haven't really done anything with this yet. I kept the form of this, right? So let me do this. So that means that the integral of this would get me back to here. And then I could put in what u is. So this is leading us to a way to handle. So watch this. Let me do this more specifically. I don't know how, anybody got that written down? It's not very useful at the moment. Okay, I want to look at that more specifically. Watch this. So g prime was 1/2 tangent x to the negative 1/2. What's the derivative of tangent? Secant. Which means dg equals 1/2 tangent x to negative 1/2 secant squared dx. So what if I ask you, what is the integral of 1/2 tangent x to the negative 1/2 secant squared x dx? Now we know what the answer is. In this case, don't we? What's the answer again? Somebody, we know what the answer to this is. We just know it, right? What is the answer to this? Tangent x to the 1/2 plus 8, right? I really want that understood. If I take the derivative of a function, the integral of the answer gets me back to the original function. That's all we're saying right now, yes? But let's say that we didn't do this shit first. I just give you this in a problem. You don't know where it came from. Does this look like an easy integral to do? Hell no! But again, if I capture the form like we did with the difference of squares stuff, I can then attack the form. You can do that with integration too, which is the neat idea. What's inside? What's the inside function here? Tangent x. So what if we said u is tangent x, yes? What would du be? Yes, secant squared x. And what we do is, this would be du over dx. But we go ahead and throw that over here. All right, let me stop for a minute. So remember when we first learned chain rule, the whole idea was, what's the inside function? Its derivative gets a turn also at the end, right? That's the whole idea of chain rule, is you gotta be able to tell what the inside function is. So it kind of makes sense to integrate something that came from a chain rule. I still have to know what the inside function was, right? If I do this, does anyone, is that cool? The tangent x is very obviously the inside function. And then its derivative is secant squared. That's not, this little thing here, that's easy as shit. But what does that mean I can do now? That means I can rewrite this. Bless you. Just like we did with the big ass difference of squares. I called that u, that v, and then I could rewrite it u squared minus v squared. Very nice. So how do I rewrite this? Let's see. What is this? What did I call this? U. And what's this? Du. Yeah, see that? So what is the variable according to my new integral? U. Yes? Do I have any other variables in here? No, that means I could do it. If there was still an x in here, this thing would die. Because the integral can only handle u as a variable, right? Okay, maybe. So the whole idea with this u substitution is let u equal a piece of the problem. Du has to be there to go with dx. And then I could write an integral that just cares about u. Sorry, it only cares about the u function, right? Is this a hard integral to do? What would happen to this integral? Let's do it step by step. That would become u to the, goes up by 1. So u to the 1/2. Divided by 1/2 is times 2, yes? 1/2 and 2 cancel. What was u? Tangent x. Isn't that this? In this case, what was c specifically if I knew this? Well, c would have been 0. But in this problem, I said I didn't give you anything. I just told you this. So you got to cover your ass and put a plus c in case there was a plus a constant. Maybe? This is weird. This is weird. I completely agree with you. This is weird. But it's freaking cool as shit. I understand. Several of you won't agree with what I just said. Alright. Let's immediately try. Let me make sure. Did I have any other things I wanted to? No. Okay. Let's immediately try a few problems here. Integral x to x squared. I'm going to try to start saying this more generally. It's not always the inside function that you let u equal, but normally it is. So let me see if I can say this. Is there a function in there whose derivative is basically in there also? Or just start off with what's the inside function? Anyone see what the inside function is? X squared. Right? Isn't that inside the e to a power function? And what is the derivative of x squared? Get really used to doing this. Do you see this? So normally we would say this. We would say u prime or du dx. But we multiply it up, and why do we do that? So that we can just say, can I find all of this in there? Can you? Can you find all of this in there? No. What do I have? I have x dx, don't I? I have that. I have x dx, right? I have that. What am I missing? My blue mark. What am I missing? Yes, the 2. Constants I can handle. If I'm missing a constant, I'm golden. Can't I bring a constant out, put it in to a limit and the sum and all, and that's all the integral is, right? So if there's a constant here, I can just pull it out, put it in, whatever the shit, they don't mind. What can I not take out? Could I take that x out?
No.
Why not? Because that's the variable that the integral's trying to attack, right? So it can't just come out and say, no, I don't want to do that today. So what did I need here that isn't currently there to be able to find du? I can't find du right now. I'm missing one thing. What am I missing? A 2. So if I put a 2 here, put a 1/2 on the outside, so overall I just did nothing, right? This is the mistake. I think Indiana Jones didn't take enough calculus courses because, I don't know, you guys have all seen Raiders of the Lost Ark? Some of you guys, anybody never seen that? It's not a prerequisite for the course, but remember the golden idol? And then he puts the bag there, right? So he's hoping overall he didn't do anything, but of course he was off a little bit. He put a 1/3 instead of 1/2 or something, right? I don't know. You guys said all with me. So I can put 2 there as long as I also put 1/2, so overall I did nothing. But now, I really want this to make sense. That is du, right? That is du. You can see it. So if you call du 2x dx, there, I can replace all that shit with du. And what else happens? So that's these are all gone now, right? I've replaced it with du. What is this? E to the u. What's the only variable in that integral? U. That means I could do it. I like it. And what's the integral of e to the u? E to the u.
Holy shit. I left out my 1/2, of course I did. 'Cause I just wanted to. Yeah, that's gotta still be there.
That's a part of the problem now.
One half e to u plus c. And then, so 1/2 e to the x squared plus c. Now let's check it. When you take the derivative, I'll do this. Derivative of c is 0. It's never not funny, Jeff. What's the derivative of this? So check it. 1/2 e to the x squared plus c prime. So I did the c is 0. What happens here? What has to happen? It would be derivative of e to something is e to that thing, right? Times? No natural log. What's the derivative inside, right? Just change it. And what's the derivative of x squared? 2x. 1/2 of 2 is gone, so I get x e to the x squared. Is that the original function I had? Right? Yes. That means it's true, it works. So if you integrate something, which means anti-differentiate, how do you check it? You freaking differentiate. Take the derivative. Does that make sense? How you guys feel? This is a weird idea. I totally understand. It takes a lot of practice. Let's try another one. Yeah, let me do one that's going to get us ready for something in a minute. All right. Really, again, there's no quotient rule. There's no product. There's none of that shit. We have to develop new rules that kind of undo those things. So I can't just take the interval at the top and the interval at the bottom and be done with it. That's bullshit. Yes? Can't do that. Okay. What function is inside of another function? Radix. So let's rewrite this a little bit. We know this is better format in general. I wish this would have been the chosen format. The chosen format. So radix is inside. Let's try this. If u is x to the 1/2, if that is what you be, right? That's what we're going to choose. Yes. And sometimes the process means picking the wrong u and then thinking, okay, it's got to be a different u. So if u is x to the 1/2, what's du? 1/2 x to the negative 1/2 dx, right? Is this, the constant doesn't matter. I can always balance the constant out. I really want that to make sense, like we did here. If I'm missing a number, I don't give a shit. I can get that. What matters is, do I have the functional piece of this in there? Is this in there? No, it is, right? Because what is x to the negative 1/2? Isn't it 1 over? Isn't that in there?
Yeah.
What am I missing? 1/2. Now again, sine is cool, right? Because what does this become? What is x to the 1/2? U. I just need to find du now. I need to find du. I really want this to make sense. I need to take everything that has x's in it, and then I need to make it have u's in it instead. That's the idea of u sub. Because then hopefully the resultant integral is easier. Or doable, period, right? So this is cool. He's just going to become sine u. I need to find du. What am I missing? 1/2. So if I put a 1/2 in here, I have to put what on the outside? 2. So the numbers, let me write that different color. The numbers I can always balance out. My apologies to anybody taking chemistry. I know it sounds balancing equations. Okay. So let's see, can I cover everything? So I got my 2. This, what is this? What is this piece? du, right? So I can replace that with du. And what does this become? Sine u. And again, this is weird, but again, I am capturing the form of what the integral is asking me to do. Sort of like we captured the form of what that factor problem was trying to ask me to do. That is the form of this. Derivative of sine u would be, the derivative of, it's going to be like cosine, right? Derivative of cosine u would be cosine u, with sine u times times the derivative of the inside. Right? I know it's negative out here. So this is here, and this would be the chain rule piece. So let's see what happens. So what is the integral of sine u? I gave it away, but
Cosine, negative.
negative. Good. I'll put plus c for you. And then what is u?
X to the 1/2.
X to the 1/2, and we can put it back like that. And to check it, you would take the derivative. Well, the derivative would be negative sine, so negative cancels, of this times 1/2, that kills the 2, x to the negative 1/2, bam. And of course the plus c goes to 0. Right? So you can always check your answer. So let me show you again. So check. If I took this guy's derivative, I'll write it like this again. Wouldn't this be negative 2 times, derivative of cosine something is negative sine of that thing, times the derivative of the inside, right? The x to the 1/2, so that'd be 1/2, x to the negative 1/2. And of course the plus c dies, right? So the negative 2 and the negative 1/2 cancel. And you get sine square root of x over square root of x, which is what we had in the beginning. So you're just packaging the chain rule piece, this chain rule piece, you're packaging it together to be the derivative of the inside, because that's chain rule, isn't it? But it's a lot easier to look at that shit than that shit. And then you're rewriting the inside function as u. So it's sine of u times the derivative of u. That's the chain rule. So this is why I call this the answer to chain rule. Weird shit, I know. Okay, let's do another one. And then we'll look at this. Well, shit, we'll do another one, that's about it. But that's all good, 'cause Monday we'll have to come back to this anyway, so it's all good. Let's do one more. What do you got, Jeff? Oh yeah, let me show you the power of this shit. All right. All right, let's see. All right, let me ask you this. What's the inside function?
I'll put that down.
What's its derivative? What's the derivative of 1 plus x? What's the derivative of x? 1 dx, right? So if I call this u, is this du? No. You guys, I want you to see that. So the inside function, if I call it u, I don't get what's outside as du, do I? Now we can take care of that, but we can totally do this problem. But, so keep some room here. What if I turn the camera, and then people at home can see what's going on? What if instead of this, I had this? Why is this now directly doable? Why is that directly doable and this doesn't seem to be? What's the inside function? 1 plus x squared. What's the derivative of 1 plus x squared? 2x. I got x, don't I? And a 2 I can make. I really want that to make sense. Yes? So it seems like right now this is not doable, but we're going to do it in a minute. Let's do this one. And I'll do this a little bit quickly because we're basically out of time. I'm missing 2, right? But again, if I put a 2, I put a 1/2, I'm golden. So 2x dx is du, and the square root, so I'll put a 1/2 of 1 plus x squared is u to the 1/2, right? Because that's what we call u, yes? Is that cool? So 2x dx is du, 1 plus x squared is u. And that integral is easy. What's the integral in that? No, come on, it's the derivative, integral. It'll go up.
You did the 3 halves.
And then reciprocal, right? And now what was u again? What was u? You just look right there. Bam! Yes? And you can check it by taking the derivative.
Did you multiply by the 1/2?
Where is it? Oh, I forgot my, I keep doing that just to be fun. Thank you. Now, this guy, I'm gonna show you something that, real quick, just to make sure you guys understand. I keep forgetting my little 1/2, but don't do that. Learn from my mistakes. I sometimes don't see professors teaching this, but let me show you this real quick. This seems like it's not doable, again, because the inside function, its derivative isn't there. I need an x here, I got 2, shit, it's too much. But let me show you this. If I call u 1 plus x, du is dx, is that cool? That's where we think that we're screwed, right? And here's the funny thing. If u is 1 plus x, what is x? U minus 1. Can't I put that there? And then I would put u there, yeah? So let's see what we get. We get the integral, u minus 1 squared, because that's what, if u is 1 plus x is u minus 1. So you just put a u minus 1 there. Square root, so I'll put a 1/2 of 1 plus x, which is u. And what's dx? du. Did I replace all my x shit with u shit? Yes. Now what do I do? FOIL this out, distribute this in. Now it's all u to the n, that's an easy integral, right? So the main problem with this was, the inside was 2 terms. If only the inside was 1 term, I could distribute shit and that'd be easy. So look what the u sub did, it made the inside 1 term. So then I could just distribute that after I FOIL this out. All right, that was a lot. But again, Monday we're gonna go through the worksheet, we're gonna really get down into the details. We still have to work out what's gonna happen if this is a definite integral. Oh, shit. So we'll see what happens. So we're gonna do that other side of that worksheet Monday, yeah. All right, that's it. Let me know if you have any questions. Otherwise, I'm sorry, Wednesday.
Okay.
I think the optimistic part of my brain is,
It's Friday. It's Friday.
so Wednesday we'll do that. Don't take the rest of the week off, it's too bad.